Hello, and welcome to TrainSignal. I'm Don Jones, and this is the security lesson in the Database Administration Fundamentals course. In this lesson, we'll be covering the high-level basics of SQL Server security, including server-level security, database-level security, Windows security versus SQL authentication, object permissions, and ownership chains. SQL Server security all begins with a login. This connects you to the overall server and gives you certain server-level permissions. There are two possible types of login. A Windows authentication login is actually authenticated either by the local computer or more commonly by Active Directory. SQL Server just takes its word for it. SQL authentication, on the other hand, is authenticated directly by SQL Server. That's useful for instances where you need to be able to authenticate to a server that isn't part of a domain or you aren't part of its domain. Logins can belong to one or more of the fixed server roles, which bundle up a variety of permissions that apply to the entire server. Belonging to a role gives you the permissions of that role. Let's quickly jump into SQL Server Management Studio and see where these server-level security objects reside. We are finally going to be leaving the Databases folder and going to the Security folder for the first time. Here you can see all of the different logins that have been created on this server. I can create a new one by selecting New Login. This server has been configured to allow either Windows authentication or SQL Server authentication. I'm just going to do a SQL Server authentication, and I'll put in my username. I'll add a password. I can enforce password policies. There's a variety of different things I can do. I can add this person to one of the server roles to give them some permissions at the server, map them to users within a database, which is something that we'll see in a moment, and so forth. Each user account created on the system has all of those different properties. Server role memberships, user mappings, securables status, and so forth. The icon here is kind of important. You'll notice that SA has a small red down arrow, as do these. That means those particular accounts are disabled. They exist on the system, but they can't currently be used. I would need to enable those in order to have them work, and I could do that from within the Properties tab. Windows authentication is always available on modern versions of SQL Server. A Windows login can either be a user or a group. If a group is added to SQL Server as a login, then all users who belong to that group in the directory are granted use of the login. It becomes a kind of shared login for all members of the group. While Active Directory is the most common authentication for Windows, local users and groups can also be used as logins. SQL authentication is not always available. It must be enabled in the server configuration. When used, SQL Server maintains its own password policies, password length, maximum password age, and so forth for the passwords on those logins. There are a variety of fixed server roles in SQL Server 2008 and 2008 R2. The bulk admin role is used for bulk insert operations. DB Creator gives permissions to create, alter, drop, and restore databases. Disk admin role provides the ability to create, alert, and drop disk files. The process admin server role can kill running SQL Server processes. The security admin role has permission to manage server logins. The server admin role is pretty special. It has complete control over server-wide settings, including full text search and the ability to shut down SQL Server. Setup admin has permission to configure linked servers and to configure extended stored procedures. And finally, the sysadmin role can do pretty much anything, including overriding permissions to which the sysadmin role has been denied. In SQL Server 2008 and 2008 R2, you cannot modify this list or the permissions assigned to these roles. Once you're connected to the server via a login, you'll want to get into one or more databases. Logins are mapped to database users within each database. A given login may map to many different users in different databases, and may not map to any users in some databases. Database users are assigned permissions within the database. Database users may also be placed in one or more of the fixed database roles and/or any of the user-defined database roles. Let's take a quick look at SQL Server Management Studio to see where these database users and the database roles all live. Now we'll go back into the Databases folder and take a look. Well, let's stick with the test database here. We'll go into its security folder, and I can see all of the roles or users. So let's see, I've got this DBO user. Let's open that up and see what it is. This is mapped to the company/administrator login. So whenever this login accesses this database, the login is represented within the database as this user. And I can see what this user owns, what database roles this user belongs to, and so forth. Any permissions I assign will be assigned to that user account. So this is really the two phases of SQL Server security. You get into the server with a login. That doesn't necessarily get you into any databases, though. Your login has to be mapped to a database user. That essentially makes each database its own little security kingdom, and it can refer to the server-wide logins to determine who the database wants to allow in and what permissions it wants them to have. There is a guest user within databases. It must be explicitly created. It does not exist by default. It is used to represent any login which has not been mapped to another user within the database. Because it doesn't exist by default, that means any login which is not mapped to a user can't get into a database. If you create the guest user, then it is possible for logins which have not been explicitly mapped to another user to access the database using whatever permissions the guest user has. There is a public role, which is a fixed role that you cannot remove, but you can assign permissions to it. All users are always members of this role, making it the baseline permissions for all users in the database. You still have to have a database user in order to get into the database, but all database users belong to the public role. There are a variety of fixed database roles provided to you. DB Access Admin has the permission to access the database but not manage security. DB Backup Operator can perform backups and checkpoints but not restore the data. DB Data Reader and DB Data Writer can read and write all data in the database. DB DDL Admin can run all Database Definition Language or DDL commands. DB Deny Data Reader and DB Deny Data Write can deny read or write permissions to any members of those roles. Those are unusual roles because they're the only ones that, by default, deny a permission rather than granting it. DB Owner has full database permission, although it cannot override any permissions that have been denied. DB Security Admin can manage database security. Note that if some combination of your user permissions and role permissions result in you having both a deny and a grant or allow of a particular permission, the deny will always override the grant. Also note that you cannot modify these roles or their permissions. You can, however, create your own user-defined roles. You can make up any additional roles you like and assign whatever permissions you need to them to accommodate your business needs. The one user that's present in every database in SQL Server is DBO, the database owner. This is the default owner for all newly created objects. You see, in addition to having permissions about who can access an object, each object has an owner. This becomes important in permission chains, which we'll discuss in just a moment. Some of the permissions that can be assigned include permission to select, insert, update, or delete data. There are also permissions for DRI, or Declarative Referential Integrity, which means creating foreign keys, and there's a permission for execute, both to execute procedures and user-defined functions. You set these using the commands grant, revoke, and deny. Grant gives you the ability to do something. Revoke takes that ability away, but it does not prevent you from using the permission if you've gotten it from somewhere else, such as a database role membership. A deny permission means you're not allowed to do that, even if you have a grant permission that comes in from somewhere else. Ownership chains are a massively important aspect of SQL Server database security. You see, when you go to access a database object, SQL Server only checks your permissions when you access a first object. If that object accesses a second or subsequent object that has a different owner, then SQL Server will check your permissions again. Permission chains make a lot more sense with a good example. So let's say I have this user here who's trying to execute a stored procedure called do this. I've given him permission to execute the stored procedure. That stored procedure in turn queries a view, and that view is built upon a table. I have not given my user any permissions to the view or to the table. So here's what happens. He runs exec sp do this. He attempts to execute the stored procedure, and SQL Server checks his permissions because this is the first object he's executing. He has permission to the stored procedure because I've given it to him. The stored procedure then accesses a view, which is owned by the same owner, DBO. SQL Server says, yeah, no problem. It doesn't even check his permissions. The view is then built upon a table, which is owned by the same owner, DBO. And so SQL Server says, yeah, sure, it does not check his permissions. Now, you might think that not checking someone's permissions is a bad thing, but it actually works out really cool. It means he can only access this data through the stored procedure I have given him access to. It's not possible for him to go around that stored procedure to bypass it. For example, if he attempts to select data directly from the table, well, that's the first object he's accessing, and so SQL will check his permissions, see that I haven't given him any permissions, and deny his access. So I've now restricted him. The only things he can do are the things that the stored procedure lets him do. Let's take another example. Same thing. My user is going to try and execute the stored procedure. I've given him permission. I have not given him permission to the view or to the table. However, this table is not owned by DBO. It has a different owner, Timothy. So my user runs exec sp do this. He accesses an object and SQL checks his permissions. Yep, you're allowed to do that. The stored procedure accesses a view, and SQL Server says, sure, the owner hasn't changed, so keep going. The view queries information from the table. Oh, but wait a minute, SQL says. We've changed owners, so I need to check your direct permissions against this object, and you don't have any. So the stored procedure execution is going to fail. Let's jump into SQL Management Studio and take a look at database object permissions. Keep in mind that permissions for database objects are always assigned to users within the database. And a database object can be anything inside the database. It can be a table, a view, a stored procedure, or whatever. So let's right-click on this view and look at its properties. On the Permissions tab, you can see that this starts off by default completely empty. We need to add a user to this view so that we can see the permissions of that user. We could also add one of the database roles to see the permissions on this object assigned to that role. So let's hit search. We'll punch in the guest account. These are the permissions on this view assigned to the guest account. I've got explicit permissions, which are the ones assigned to this object, and effective permissions, which are the ones that result from all the different layering of permissions that come on. So let's just say that we're going to allow the guest account to select information from this particular view. I can even get down to the column level. I can say, well, I'm going to allow them to select names, but I'm not going to allow them to select addresses. You'll notice that because I haven't completely assigned full select permissions, this checkbox is grayed out. If I click it, it goes dark, and that means I've now given permission to the entire row. So we'll come back in here and just do on the name column, we'll hit OK, and that permission has now been assigned. So that's how all of these permissions can be managed across databases. Some bonus information for you on SQL Server service accounts. SQL Server's actual software, its executables, are designed to run as background services in Windows, and services have to log in order to run. These log in using Windows local or domain user accounts or built-in accounts. A local account is good when no network access is needed because SQL is then restricted to the local machine. A built-in system account is also okay. It provides no network access and it's good for single server installations. It can be a potential security hole simply because the system accounts tend to be very highly privileged. SQL can also be configured to run under a Active Directory domain user account, and that's good for all other scenarios and is generally the recommended approach, especially in a production environment. Let's jump into SQL Server's configuration tools and take a look at its service accounts. Service accounts actually are not configured anywhere in SQL Server Management Studio. There's a separate utility, SQL Server Configuration Manager, where that's done. Here I've selected the SQL Server Services item in the tree, and it's showing me all of the different services that are installed for SQL Server on this particular computer. You can see that I actually have two instances of SQL Server running. One looks to be a copy of SQL Server Express, and the other looks to be a full copy of SQL. Each has an instance name. I can see the account that these are running as, and if I right-click and select Properties, I can even change that account. Local system, local service, or network service are the three built-in accounts I could use, or I could change it to run under a particular local or domain user account. In this lesson, we've covered the fundamentals of SQL Server security. We touched on server-level security, logins and roles, database-level security, users and database roles. We discussed the differences between Windows security and SQL authentication, talked about object permissions, and discussed ownership chains.